Hello! Today I am going to talk to you about something I am sure you all are very familiar with breathing. Our goal for the STEM project is to create an interactive model that has the ability to explain clearly how the process of breathing works. For instance, when we breathe, have you ever considered how many factors come into play? It's a pretty complicated process now that you think about it, huh? So, if I want to explain how a model about breathing works, first I must explain how the actual process of breathing works in on itself. When you breathe in or inhale, your diaphragm contracts and moves downward. This increases the space in your chest cavity, into which your lungs expand. The intercostal muscles between your ribs also help enlarge the chest cavity. They contract to pull your rib cage both upward and outward or mouth. The air travels down your windpipe and into your lungs, after passing through your bronchioles and enters the alveoli. Through the very thin walls of the alveoli, oxygen from the air passes to the surrounding capillaries or blood vessels. A red blood cell protein called hemoglobin helps move oxygen from the air sacs to the blood. At the same time, carbon dioxide moves from the capillaries into the air sacs. The gases travel in the bloodstream from the right side of the heart through the pulmonary artery. Oxygen-rich blood from the lungs is carried through a network of capillaries to the pulmonary vein. This vein delivers the oxygen-rich blood to the left side of the heart. The left side of the heart pumps the blood to the rest of the body. There, the oxygen in the blood moves from blood vessels into surrounding tissues. Now, for breathing out. When you breathe out or exhale, your diaphragm relaxes and moves upward into the chest cavity. The intercostal muscles between the ribs also relax to reduce the space in the chest cavity. As the space in the chest cavity gets smaller, air rich in carbon dioxide is forced out of your lungs and windpipe, and then out of your nose or mouth, depending on which you use. Breathing out requires no more effort from your body unless you have a lung disease or are doing a physical activity. When you're physically active, your abdominal muscles contract and push your diaphragm against your lungs even more than usual. This rapidly pushes air out of your lungs. So, to make a model representing how this system of inhaling and exhaling works, we developed a prototype to see how we could achieve this. Logically, the process involves two major chemical compounds, carbon dioxide and oxygen. Oxygen is breathed in as a waste product. Carbon dioxide is exhaled. For the materials in the creation of this project will include some styrofoam balls, plastic lungs, some vacuums, hoses or transparent tubes, if we can find such a thing at least, a metal stand, and a model for the nose, mouth, and chest cavity. The model should work like this. Comprising of a couple of tubes and vacuums, we will transport some styrofoam balls through a model representing the chest cavity that has the major organs that take part in this process: the lungs, trachea, mouth, and nose, and also the oxygen-carrying veins. The styrofoam balls will represent a gas, black for carbon dioxide and blue for oxygen.
So, in conclusion, the making of this project means that we will make a perfect model for children or for other people to learn about the respiratory system. When we do this, we want to present an easy and fun alternative to describe how it works. It was quite imaginative on my part, I guess, to make the styrofoam ball decision, I guess, to make the system work.